So 5 and 7. So if we're taking a look at number 5, someone want to tell me if you were looking at number 5, what would you have done first? Because we're still solving for y and all. And there's a couple different ways of doing that one. Well, what did anyone do first in maybe 3, 4, 5? What could we do to get the y by itself? Raise your hand, some Aaron. We could have subtracted the x. What else could we do besides subtracting the x term? Because we are trying to solve for a positive y, right? We want it to be 1, 1. So instead of doing that in 3, 4, 5, what else could I have done this word? Instead of subtracting the x term, I could add y. So if I look at number 5, I might have added y to both sides, right? If you didn't do number 5, make sure you have this down. Most of you were pretty far on this yesterday, so I have 3x. This is still an equal, and I have negative 10 plus y. Now I still want to get this y by itself. So Nikita, what would I do to get this y by itself now? I would
add 10.
Add 10. So I add 10, and we notice that all the answers are in the form where they have the x term first, and they usually don't have the y behind it. So when you're looking at that, someone said, well, instead of putting the y behind it, can I put the y out in front? Yes, it's the same. 3x plus 10 equals y. Y equals 3x plus 10. Okay? So as you are looking at that, okay, this kind of leads us into what we're doing today. So number 7, okay, we're going to look at number 7. In number 7, as I look at that one, I'm going to start off and do what first? Someone to suggest to us what we would do first as we look at the problem. What do you think? Any ideas? What would you do first?
Minus the 2. Yeah. Wait. No, divide by.
You divided everything by 2 first. We could do that. So is it possible? And the reason, you just got to be really careful because you're looking at just this number in front, right? So we might have this as plus a negative 2. So we kind of just got to be careful what we divide by. So we could divide first. My hint would be do addition or subtraction first. So if I am looking at that, Olivia, what do you do? Is it Sophia? Okay, Sophia, what are you going to do? Add this 2 back here. Oh, add 2y. We could add 2y. Did anyone subtract x? Okay, so I'm going to show it both ways. So here we have 1x equals 2y plus 2. Kyle, if I get to this point, what do I want to do next? And I want you to notice I put that 1 in front of x, but I got to get 2y by itself. I could divide, but I still want to get 2y with nothing else added to it.
Subtract 2.
Do what?
Subtract 2.
Yes, subtract 2. So if I do that, and I'm looking at that, Jaden, what am I going to get here? So if I have 1x minus 2.
1x.
So I'm going to keep the 1x and just minus 2. What do I have left on the other side of the equal sign? 2y. And now, Haley, I'm going to do what?
Divide everything by 2.
Divide everything by 2. So a lot of you yesterday on that worksheet left something like this too, and you would leave it as x over 2. And if you notice the answers up here, they don't have x over 2. And that number is a 1/2 in front, so it's 1/2 x minus 1 was equal to y. So Chase, you said you had some questions.
That's question 7 also. So like, I got y equals negative 1 plus negative 1/2 x.
Okay,
I mean,
so
same answer.
negative 1 plus 1/2 x. Is it the same? Yes. We talked about the other day of trying to get them in this form of putting the x first. I would not mark that wrong. If you put down the answer for this problem and you said, for number 7, and you said y equals negative 1 plus 1/2 x. I am not going to mark that wrong. That is correct. That is what y is equal to. The reason we put it this way is pretty soon we're going to be talking about slope-intercept form and graphing, and gets us into algebra, and you will use this for the next 3 years of your math. So if you can get used to putting it in the form where you have your x first and then your number, it's just going to make the rest of this year and next year easier, okay? Other questions on that last column? Anyone you want me to take a look at there? Anyone that just threw you off, you're not sure about. This would be a good time. Jenna, Nathaniel, anyone else? Colby, you got any? No? You're good? Any other one? You want to pick another one? Jeremy? You good? Kyle? Yeah. Okay. No one? We're good? All right. Oh, good. This is good. So, if you had that page completed, now I better plug in my volume for you. I know it. We're almost done. This unit's been going on forever.
Let's learn about literal equations. If we take a look at the name, it looks like a literal equation is a type of equation. And that's right. Now, an equation identifies a relationship between the left and right-hand sides of the equal sign. Now, to help us see a literal equation, let's go ahead and explore some equations. So, let's write a few equations down. Let's say we have this. X plus 8 equals 12. This is an example of an equation. We have the left and the right-hand side of the equal sign. Here we're saying that x plus 8 is equal to, or the same as 12. We're saying that the left side is the same as the right side. Now, we can also have something like this. 7x equals 21. Here we're saying that 7x is the same as that right side 21. Or we could even have an equation like this. Y over 2 plus 5 equals 7. This is another example of an equation. Now, all of these are typical equations that you might see. But there are also some other equations that you might see as well. Let's take a look at those. Let's say we have 3x plus 2y equals z. Here we see we do have an equation, but it's a little bit different from the ones we just saw. Notice, this equation has three variables, x, y, and z. All of these equations only had one variable. Now what if we had an equation like this? D equals r times t. This is another equation. But notice, this one just has variables. Three variables, and no numbers. Or what if we had something like this? A equals 1/2 times b times h. Here again, we have more than one variable. Now, each of these equations that has more than one variable gets a special name. These equations are called literal equations.
There you go.
A literal equation is an equation that has more than one variable. So, each of these equations that has more than one variable is called a literal equation. Now, to help us gain a little better understanding of these literal equations, let's go ahead and take a look at some more examples. The most common type of literal equation is a formula. So let's look at some of those. Here we have A equals L times W. We can see this is an equation where the left and right-hand sides are equal. And we have more than one variable, A, L, and W. So this is a literal equation. This is actually the formula for the area of a rectangle. In this formula, A stands for the area, L stands for the length, and W stands for the width. Now, usually with formulas, we're given values for some of the variables, and we need to solve for the unknown variable. So say here we were given the area and the width, but we were missing the length. Well, in that case, we could plug in the values for the variables that we had, and then solve for the unknown variable, like L. Neat. Now, we can also have one like this. I equals PRT. This is a literal equation. It's the formula for interest. I is interest, P is the initial amount that we invest, R is the rate, and T is time. Or we could even have a literal equation like this. P equals 2L plus 2W. This is the formula for the perimeter of a rectangle. P is the perimeter, L is the length, and W is the width. Now, we can also have literal equations that look like this. Y equals mx plus b. This is a literal equation. It's actually the slope-intercept form for a line. Neat. Or we can also have one like this.
It's always
AX
me.
plus BY equals C. Another literal equation. This one is the standard form for a line. So now we know more about literal.
Is going to be, it's always going to be an equation with one or more variables. So when we looked at ours today, we were having the y solving for x, but equation with one or more?
Yes.
More than one. More than one variable. And they gave you a bunch of examples, and if you look at that next page down in your notes, these are some of the common literal equations or formulas. Ooh. So they gave us the first one, right, in the video. Perimeter equals 2L plus W. Circumference is equal to pi times radius. Length times width is area. Area of a triangle, 1/2 base and height. We used that one earlier this year. Area of our triangle, pi radius squared. Distance. You kind of worked with that in science where you had that distance triangle, right? And if you think of that, where we had distance, rate, and time, so distance and rate and time, so you're solving for one of the other variables. And then our last one is our temperature, Celsius, with 5/9 times F minus 32. So if we are taking a look at that, we now want to solve on the top of that next page for L in this formula. That means I want L by itself. So I look at the formula, and Nathaniel, what's happening between the L and W? What operation between that L and W? Good, what? Multiply. So the opposite of multiplying is to divide. And we want L by itself. So we're not going to divide by L, we're going to divide by W. And now we're going to put the L first because it said solve for L, and we're going to have a area divided by the width. And you're done. That's it.
That's it.
That's it. That's it. So let's go to this next one. We're trying to solve for W. This is kind of like our solving for Y today. Okay? Logan, I want to get the 2W first all by itself. What do you have to do to get rid of what's up? Whatever else you say it one more time. Well, I could, except I want this 2W here with nothing else, nothing added to it. So how do I get rid of this adding 2L? Subtract 2L. So we're going to minus 2L. And we're going to do that on this side of our equal sign. And on this side, are these like terms? The P and the 2L? No. So we're going to write it as P minus 2L equals 2W. Ella, next step. I want 1W. What's happening between the 2 and the W? Multiplying. So the opposite of multiplying is going to be to divide. We're going to divide every single thing by 2. So there's two ways you might see this answer in the back when you're checking it. You might see it as P divided by 2 minus 2 divided by 2 is just 1, so we might have P divided by 2 minus L. That might be one way that you're going to see that answer in. The other way that I would also accept for the correct answer would be that you put W is equal to and you put P minus 2L all divided by 2. So what they did was they just put the whole thing divided by 2. I would take either of these answers. This one I think is a little better, but I would accept both. Does that make sense as you write them both down? Yeah. Some of you didn't write them both down. Write them both down, Jeremy. I would take 1/2 P. Same thing, right? So if I have 1/2 times P minus L, but did you put this answer down also? Put this one down also. Usually if they use lowercase letters, keep lowercase. If they use capital, use capital. Okay? And usually there's a reason for that, like area, perimeter, circumference. Those are oftentimes capital ones, whereas when you take a look at a side or a length, they might not have them that way. So these next ones down, it says solve the literal equation for the specific variable. So this one says we want to solve for M. So start me off, we have to get the mx. If we think of our highlighting yesterday, I need this m and x by itself first. What are you going to do, Gunnar? Start us off. I don't want to subtract mx. I want mx all by itself, so plus b. I'm going to subtract b. Okay. So we're going to subtract b. Left Maddie with what? Yes. Next step, down we have m times x, and I want just the m there. What operations happen when those two are written right next to each other?
Oh, well, you, it's a multiplication.
Yep. So inverse of multiplying is?
You divide everything by x.
And divide everything exactly by x, because we're trying to find m. So this now gives us 1 over 1, right? That gives us our m. And I can put this whole thing, so I can put m equals, and I'm going to have y minus b. And I would just, if they told me what y, b, and x were, I would just plug those numbers in, and I would be able to find what m is equal to. Okay? This next one over here. Jaden, you ready to start us off? You want to get the h by itself. So one thing I might want to do is I have this minus 2h. I might even want to rewrite that as plus a negative. I want to get that all by itself on that side of the equal sign. What are you going to do?
Minus 7.
Wait, what's on this side of the equal sign with the negative 2h? Okay, so I have to get rid of the 3g first. So I'm going to minus 3g. Do I have any g's on this side? Nope. So I'm going to put it way back here. I'm going to put minus 3g way in the back because it's not like any of them. So I now have negative 2h. Tell me what I'm going to have, Jack, if I write everything down. I'm going to have what? K plus
7.
Yep. Minus
3g.
Yes. Very ugly looking, right?
Yeah.
What are we doing to finish the problem?
You're gonna divide by negative 2.
Divide everything by negative 2. And I can put this whole thing over negative 2. I could do each one individually, but nothing's going to simplify, right? 7 over 2 doesn't simplify. 3 over 2 doesn't. K, that would be like 1/2 k. That'd be like negative 7 over 2. That'd be plus. I can leave it like this. So I'm going to leave my h as equal. I want you to try the 2 on the bottom. Try this one first, the circumference one. Solve for r. Try it, and then we're going to look at that, what you did. Try it. So try the circumference one, and then we're going to look at the area one. I have 2 times pi times r. What do I have to divide both sides by? 2 and pi. Because now that gives me 1 over 1. 2 pi over 2 pi, and over here I'm going to divide by 2 pi. Am I now going to have 1r? Yes, because those cancel as 1 over 1. So r equals, do you see how this one was even easier than our other ones? Like we didn't have as many steps. You're just dividing. Everything was being multiplied. So I always have students when they look at this one go, oh, Mrs. Thompson, I think we should clear the fraction first, right? Like we've been doing all those, which means I'd multiply by what on both sides of the equation? 2. So I'm going to take 2 times a, right, is equal to 2 times 1/2 times b times h. Next year at the beginning of algebra, you guys kind of start with the same stuff. You start solving equations. They get a little harder. They kind of got some of the ones like we have had in this whole unit. We're almost done with this unit. But then you get into more literal equations. 2 times a, just leave me with 2 times capital A. 2 times 1/2, that's just going to be our 1, right? So we're left with b times h. Base times height, right, equals 2a. But we want to find only the h. Jeremy, what do you think I'm going to do? Divide both sides by b, right? So I have b times h, so I am now simply going to take and divide both sides by b. And my answer for h equals 2 times capital A divided by b. So Your homework is D14. It's 1 to 12 all.